In this lesson we're going to look at the scalar product. So far we've added and subtracted vectors, but we haven't looked at any sort of multiplication. This is a form of vector multiplication. It's also known as the dot product, and as you can see you've got a dot b is equal to magnitude of a magnitude of b times cos of theta. So this dot really means multiplication. In our system a dot doesn't mean multiplication. We usually use it as a decimal point, and we use a cross for multiplication, but some mathematical systems use a dot for multiplication. So theta is between 0 and 180 degrees. Now let's have a look at the ray diagram here. So theta is the angle between the two vectors a and b, and the vectors have to be set up a certain way for this to work and operate like this. Now the formula is given in the exam, and it's given in a formula sheet, so you don't have to memorise it, although it is quite easy to memorise. So this next screen is important in the sense of when you can use this and how you can use it. So the scalar product definition works for the vectors below. This is the same idea as when you add vectors, you have to have the vectors nose to tail. To use this formula we need the vectors either both pointing away from the angle or both pointing into the angle. And then we can use the formula like this. If we have this situation where a vector is pointing out and one's going in, or one's going in and one's going out, we have to reverse the direction of one of the vectors, i.e. make it negative. So the formula stays the same but has a negative in front of it. That will not be in the formula sheet. So let's look at some examples. Two vectors a and b have magnitudes 7 and 4 respectively. They are at an angle of 60 degrees to each other as shown. What's the value of a dot b? So if you couldn't remember the formula, you would go to your formula sheet and you would read off magnitude of a times the magnitude of b times the cos of the angle in between. Now the two vectors are pointing away, so we can use this formula quite happily. So we've got 7 times 4 for the magnitudes up here, and cos of 60. Now we need to know the exact value of cos 60, which is a half, so we can have 28 times a half, and that's 14. Next example, find the scalar product for vectors a and b. So we're told the magnitude here is 3 of a and b is 4. And we're told the angle is 30, but notice in this case we've got nose to tail. We don't want that. We want one of the vectors, or both of the vectors, sorry, either pointing in or both pointing out. So we reverse one of the vectors and make the formula have a negative in front of it. And then we just do as we did before, so we're going to have a 3 and a 4 and a cos 30 with a negative. So that's going to go to negative 12, and cos of 30 is the same as the sine of 60, which is root 3 over 2. So the negative 12, you could sit at the top, but you'll divide it by 2, so we really get negative 6 root 3. And finally, last example, find the scalar product for vectors a and b. Magnitude of a is 11, magnitude of b is 6, and in this case theta is 90 degrees. Two vectors are pointing away from each other, so we can use the formula as it is. It's going to be 11 times 6 times cos of 90. Now the cos of 90 is just 0, so you're going to have 66 times 0, and that comes out to be 0. Now this result can be used, as we say here, to prove vectors are perpendicular. If you multiply the vectors together and you find the answer 0, it proves that they're perpendicular to each other because there's a right angle between them. Because the cos of the angle 90 is always going to be 0. So it doesn't matter what these bits are, it's always going to knock it to 0. Sometimes pops up in non-calculator multiple choice questions, and also sometimes appears within other questions.